Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 certification exam preparation course, and in this lab 3.6.6, we're going to take a look at parsing different data types with Python. The focus in this video, and we're going to break it down to make it nice and digestible and easy to understand, is part number 2, where we're going to be taking a look at XML. Now, I am not a huge fan of XML. I'll say that right out of the gate. The best analogy that I could give you is that Perl is to programming languages what XML is to markup languages. Simply over-confusing and just riddled with all kinds of complexity. But we're going to break it down. We're going to make it super easy to understand. And you're even going to see some use of regular expressions using Python. Again, we're going to be doing all of this using Python. So let's go ahead and transition here over to our virtual machine. Now, I'm in VS Code on our virtual machine, and while this is not the XML file we're going to be working with, we want to start with a simple example. Because if we start small, when we go to do the actual myfile.xml file, which is in our parsing directory on the virtual machine, the DevASC virtual machine, it will hopefully make a little bit more sense. So let's say that this is our XML document. And the root of the document is book. And the root is defined as the first non-XML declaration tag that you see inside the XML file. So you could have an XML declaration tag, which would look similar, excuse me, to this right here. And you typically see this at the top of an XML file. Again, I've just omitted it here because we're not going to need it. But that's the XML declaration, and the root of the XML file is the first set of tags. Now, they don't have to say root, as you can see with my example, right? Ours just say book, and that's the first non-XML declaration tag. And so that would be the root. So how could I parse this data in here? Well, let's go ahead and take a look at the XML parse script. It's kind of a one-off script that's different from the one we're going to see in the lab. But again, this is going to give you an idea as to what we need to do to parse and manipulate the XML data. So what's the first thing we do? Well, we're going to see another way that we can import libraries, and that is we say import xml.etree.elementtree, and you can see here lightweight XML support for Python. It's inherently hierarchical data format, right? And it's going to help us represent the XML data in a tree, right? Or as a tree. And so we say as ET. Think of this as an alias. So I'm importing all of this, but later on in my script, I'm going to refer to it as ET. And again, it doesn't have to be ET. I could alias this to anything. I could have said, E tree if I wanted to, or E tree like that. So we're just using capital E, capital T to represent this library of modules and functions that we're going to be pulling functionality from. So the first thing that we do here, we create the tree. And the way that you do that, if I hover over the ET here, is we're using the element tree functionality, the method parse, to pull in my book.xml text that's in that XML file. And we're going to create an element tree object, or an element object named tree. So once I say et.parse, right? So et is our class, if you want to think of it like that, and .parse is the method. It says function here, but we know that when it's tied to a specific class, it's a method. So our class, our method, and what is the method going to do? Well, it's going to pull in this book.xml text, and it's going to generate a tree, right? And I want you to think of a tree as like a hierarchy. And so the top of the hierarchy starts where? It starts at the root of the tree, just like the Linux hierarchy starts at the root directory at the very top. And then from the root directory, you span down into all of the different directories underneath root. And how do we define root again? Well, it's going to be that first tag that we see after the XML declaration statement. And so for us, it's going to be book. So what are we going to do? We're going to say root, and it's going to get the value of the tree element or object that we just created, dot get root. So it's going to return the root element. And I've got some print statements in here to help us kind of understand as we go along. So the value of the tree.getRoot method call is, and I'm using the string format method in order to print out the statements here. It's a little bit easier. And we just say root. So we're going to print out exactly what root comes back with, right? And then to see the tag for the root, we use root.tag, right? So if I'm curious to see, okay, well, this is going to give me the root element of the tree. Well, maybe I'm curious. I want to see what it is. So I can say root.tag. And actually, this is actually missing. And I just realized this. Root.tag. There we go. So we want to see the tag that actually represents the root of the tree. And so once I have that, once I know what the root element is, I can then iterate over the child elements that are in that XML file. So let's look at our setup here. Well, book, well, what would the child elements be in the tree? Title, author, and price. So here's the root element, book, and these are the child elements with these tags. And so that is all this for loop is going to do. So for child, and again, that is just a placeholder. I could have said for children. I could have said for subroot element, but we're just going to say for child in root. And what is root? Again, root is simply a tree hierarchical representation of the XML document that we've pulled in. And so here we see the XML tag is, and I put child tag because I want to print out what the tag of the child element is first. And the text is, and here we're not using the format method. We're just using a regular print statement. Or we're not using the string format method. And then we put child.text because that is going to tell me the text that's inside of that element, that child element. So we're going to see the tag for the element, and then we're going to see, think of it as like the value. Like what's the value between these XML tags? Now, when we create that element tree element, right, and you can see root, right, is tree.getRoot, there are other methods that we can use. So we can use find, and we can search for or try to find a string called title, right? And where is title in here? Title's right there. So I can search for a specific tag if I wanted to by trying to find that tag. So here we're just going to go through all the children. But what if I wanted to just find the title of a tag, the title tag in the root element in the tree? Well, I could do that. I could say title gets the value of root.find, and I'm looking for the string title. In other words, the tag that has title. And then I can print out title.tag, title.text. In other words, the tag that's being used for title, and then the value, the text in between the tags. And then we do the same thing for price. So let's run this, right? And now we should have a pretty good idea as to how this is going to go. So take a look at what we get here. So actually, let me give us a little bit more room to work with. So you can see right here, the value of the tree.getRoot method call is this element object here, right? Element book. And what is that? It's just simply a hierarchical, visualize just a tree representation of the XML data. Similar to the hierarchical representation you see when you look at examples of the Linux file system hierarchy. And then we type in here, or then we print out, to see the tag for the root, we use root.tag, and the value is book. So that's the value of the root element tag. It's just book. And we saw that in the XML text. And so here the XML tag is title, the text is The Sun Also Rises, the XML tag is author, the text is Ernest Hemingway, and this is just us parsing, pulling out the information that we're interested in, right? The XML tag is price, and the text is $9.99. The title, and this is when we, excuse me, do our find. The title is Sun Also Rises. Again, this was the result of the for loop, just simply working through every child element in that element or in the element object tree. And then this was when we specifically went in and said, hey, inside of this root element, give me the value for what's between the title tags. Give me the value for what's between the price tags. All right, so this is kind of the scaffolding here and the preparation work that we need to understand before we get into what we're going to be parsing here. Now, remember, this is going to be in the labs devnet parsing directory. Let me clear out here. Sorry, let me say clear. We'll say ls. And so let's take a look at myfile.xml. So as you can see, there's a little bit more going on in here, but I do appreciate that this is not like that JSON search file that we had, which was just a monster file with JSON data. So what do we see here, right? Well, it's the XML declaration. So what is the tag that would be the root tag here? It's the first tag after the XML declaration that we see, which is this RPC, and then it's got a bunch of information in here, and you can see it goes all the way down here to the bottom, right? So everything is kind of underneath this RPC remote procedure call tag. Now, this right here, we're going to see this information a little bit later on. So what is the uniform resource name? And that's what this EARN stands for, uniform resource name. And I want you to think of it as all you really need to know about this is in XML that this is just going to uniquely identify the namespace, right? And you can see you got the IETF, parameters, XML, namespace, netconf, right? So this is uniquely identifying this netconf namespace down to base 1.0. And this is something that ends up getting registered officially, but we just refer to it as the XML namespace. And we're going to be pulling this out, matching on that XML namespace information. So then you've got edit-config. And under here, you've got target, right? Default operation. And we've got some other XML data that we're going to be working with. So again, this is the file that we're going to be parsing. Now, the script that they have us create, and again, I appreciate that they give us the code, but we need to kind of understand in a line-by-line fashion what exactly our parsexml.py file is doing. So let's go up to the very first line up here. And this is all you're going to see initially, is that first line right there. So we need to add everything else in. And I've put some really good comments in here to hopefully clarify what exactly this Python file is doing. So here's that import statement, right? The xml.etree.elementtree as et. Again, we alias out all of that so that later on in the script, we can just refer to it as et, right? Excuse me, to represent element tree. And then we import RE, and we'll talk about this. This is a regular expression module, right? And you may be saying, wait a minute, regular expression, that sounds familiar. And it should, because remember when we looked at grep, global regular expression print. And so the regular expressions that we would use are going to be very similar to those that we saw with grep. And again, we're going to see the example excuse me, of doing a match, right? We're going to try to match something, match a regular expression. All right, so let's go ahead and let's cruise down a little bit here and look at this next line. So again, this is the same line that we saw back over here in the XML sort of primer that we were doing, which is, oh, okay, I need to create an element object from the XML etree element tree of that class, right? And how do I do that? Well, I parse, and we give a source file name, right, containing the XML data. And that's what we're going to do right over here. And that's exactly what happens. And we call it XML is the name of the variable. And so into that variable gets pumped a copy of all of that myfile.xml data, right? And you can see I've got a comment up here telling you exactly what it is doing. All right, so let's continue down because we'd seen that line before. So the next line takes the XML object we created above, and using that getRoot method on the element object, which is XML, what do? Oh, and it looks like I left off the first tag. That is RPC. There we go. All right. So this just creates an element object that represents some element in the represents the element in the XML document, the root element, and it's going to contain its tag, attributes, and children, right? So remember, this is creating that hierarchy for us that we would see. Now, I've dumped these two print statements in here, and it's always a good idea. It's a great, not only is it great troubleshooting, but it's a great way to kind of understand, like, okay, well, right here at this point in my Python script, what is the value of the root variable? I want to see that. And what's the root tag? Maybe I want to see that. And here I'm using the string format method to make this a little bit easier. Remember, the curly braces, this is not representing a directory when we're using it with the format method, the string format method. It's just a placeholder for this value right here that we are putting in between the parentheses for format. And yes, you can have more than one value in here, and you can have many sets of these curly braces if you wanted to. So that's what that root XML get root does. The next line of the code, and this is the most confusing because this is the regular expression line. Now we create this variable here called ns that's going to represent that namespace, right? And remember that uniform resource name, or the earn, it's just a way to uniquely identify or uniquely ID that namespace. And so we're going to try to match, right? So here is our regular expression, and this is what we're trying to match right here. And so you say re.match. So match is the regular expression method that we're using to match something. And inside the parentheses for this method, we give it what we're trying to match and from where are we trying to match it. So whatever root.tag currently is, we're trying to match this. Well, what is that? So that is basically saying I'm trying to match a curly brace followed by 0 or more occurrences of any character. And that's what dot asterisk represents. So the dot is the dot is any character, and the asterisk is 0 or more of any character. Then followed by the curly brace. And we enclose our regular expression because we got special characters in here, right? We enclose it in the single quotes. So that is the string that we're looking for, right? Okay, and we're looking for it in root tag. Now this, again, this is kind of taking it to the next level with regular expressions. All the group 0 means is return the full string that is matched by the regular expression. Because we could say group 1, group 2, group 3. You can have different group numbers, but that takes us way outside what we're going to need to understand for this script and this course with regular expressions. So just know that group 0 means give me back the entire string that was matched by the regular expression. And then what I do here is I'm going to print out the value of ns because maybe we want to see, like, I want to know, like, okay, well, what does all this match? Well, let's print that out, right? So that we understand what it is we're doing here. Okay, so the next lines use the element objects methods provided by the XML eTree element tree module to navigate parse the XML data. So you can see here we're using find. If we go back over to our script that we had and we take a look, what did we use? Yeah, we used find. We used get root, right? Or the dot tag on that element or the dot text. But here we're using the method find, which is the same thing we did over in our little easy script over here. So let's take a look, and what is it that we're trying to find? So we're saying root, right? That element that we created that represents the root, we're going to find, and in there, I'm looking for edit config. And then I'm going to say dot format in S, right? And so I'm looking for this edit config with the format namespace, okay? And then we capture that in this edit conf file. Or I'm sorry, this edit conf variable name, because we're going to use the variable name later on to perform additional matching. And so maybe we're curious, what is edit conf? So how would we do that? And I kind of save this here. So we would come down and I could say print the value of edit conf is currently, and then we give our little curly braces. We terminate the string and put format, and then we capture what is it I want to see, the value from edit conf. And again, there's definitely more complex things you can do with this, but this is pretty much the easiest way. And the same thing is true here. What if I wanted to see the value of def op is currently open curly brace, close curly brace, close the quote down, dot format, and I could do def op. All right. And so let's see, I need one more there. Whoops, sorry. Need one more. And then we want to come down and we want to see what are these values. The value of, what are we doing? Test op. Test op is currently open brace, curly brace, placeholders, right? Dot format, and then test op. And I need to make sure I get the two parentheses there to close it out so we can see what those values are. So then down here at the very end of this, right, and this is kind of the goal here is to get it to put the default operation, which is what def op stands for, and the test option, I think it's test option, not operation. It's default operation and then test option. And we want to print those things out, right? So the default operation contains, what does it contain? And we want the text. So this is a way for me to say, take this object and say dot text behind it to give me just the text, because up here we're not going to see just the text. We're going to actually see what those values are, and then we're going to say, give me the text, or we're going to see the object representation of that. So let's run this, and we've got a bit to discuss here after we run this, and I'm going to say, oops, we'll say Python 3 and parsexml.py. All right, yeah, and we end up seeing the value of test op is just, we get the element object, right? But we also do see some information there. So here we go. Let's take a look at the very beginning, right? The value of the root variable is what? Well, it's just, here's the memory location of the element object in memory, right? And this is that location. Now, take a look here. You can see it tells you that it's from that RPC. And this is what we get back, right? So this was at the very beginning where we were just like, hey, okay, well, give me the whole root object, right? And then we kind of hone it down. So the value of the root tag is, and this is before we pull out any values here, before we do a match with a regular expression, here is the value of that root tag, which is this uniform resource name identifier, right? I uniquely identify this. And then we do that regular expression match where we want the value of the variable, and we don't want that RPC, right? I just want the value of the variable here. That we'll say it's a netconf URN. And you can see what happened. What did we match? We matched the open brace followed by 0 or more of any character followed by a closing curly brace. So we got exactly what we wanted, and we didn't get the RPC because we don't want that, right? So here it is, right? What is the value of edit conf? Well, it's currently this element right here. And you can see it's the URN IETF base all the way down to the .0. Okay, so the value of def op is currently, and this is after we ran the def op statement to assign that variable a value, and then we get the value of test op is currently, and again, this is printing out the object representation of the element objects that we were creating with those variable name assignments. And we'll go back in and I'll show you exactly where that was again. And then finally, we use these objects, right? And we say, okay, show me the text, right? The default operation contains what text? Merge. The test option contains what text? Set. Well, can we see that? What if I go back to my file.xml? Yeah, take a look. Test option set. Where do you see merge? Do you find it? Yeah, it's right above it, right? The default operation is merge. The test option is set. And this is how we can parse this XML data. And if I go back into the script, right, this is how we can parse that XML data to pull out just the little strings that we're interested in, right? And again, here we are creating element objects, and then we printed out the actual representation of the element, right? The def op for the default operation, the test op for the test option, and then it's down here where we say, give me the default operation. I just want to see the text, right? What's the text in between those tags? The test option, give me the text that's between those tags. And that is what each and every line in this Python script is doing. Again, lots of code in here, or so there are lots of comments in here, making it look like it's a whole bunch of code. But again, it's really not. All right, well, that is going to close out, and hopefully you've got a much better understanding of what we were doing in part 2 of Lab 366, where we were parsing all of that XML data. All right, as always, thank you for watching, and I hope to see you in the next video.